All right, let's pick this up for round 3 today, and this will be, we hope, most of the rest of the problems, but if not, we'll pick it up. So I think our last problem was number 14, or 13, so we'll look at number 14 and ask you how many moles are in 4.2 times 10 to the 22nd molecules of HNO3. So we look at our mole map. We're at number of particles. Molecules are a type of particle, and we want to go to moles. So all we have to do is a nice one-step problem, which will be divide by 6 times 10 to the 23rd. So we'll take the number of particles divided by 6 times 10 to the 23rd. That'll get us to moles. So we'll go back to our problem. And real simply then, all we have to do is we'll take our number of molecules, 4.2 times 10 to the 22nd, and we'll take that times 1 mole over 6.02 times 10 to the 23rd molecules, and the molecules will cancel. That'll give us moles, and that's going to equal 0.070 moles. Alright, I copied this in incorrectly in the wrong order, so what we're going to do is we're going to zip way down to number 15. And on this one, this is a little bit tougher problem. Matter of fact, I'm going to go ahead and blot out the rest of this because this is going to take us a little bit of room. This one probably takes the most room of any problem we have on here. They're asking us about 3 different things. They want to know which one has the greatest number of atoms in it. So we're going to have to do a little bit of analysis on this to look at what kind of particles we're given and what information we're given with it. This one's 82 liters of argon. The second one, and that's a gas, not a solution. That's a gas, argon. So that's going to be liters of argon. Hopefully, I wish it would have said gas there. Then we're going to do 5 grams of hydrogen gas, which is H2. And then our third problem, I'm going to try to get all these on the same screen, is 1.8 moles of iron 2 oxide, which is FeO. So we've got to get all these to atoms. The nice thing is this is already an atom, this is a molecule, and this is a molecule. So the first thing we have to do is convert these liters to moles and then change it to atoms. So we'll take 82.0 liters times, if we look at our mole map, if we're at liters of gas, to get to moles, we'll have to divide by 22.4 liters, and then we'll have to go to the number of atoms over here. Remember, atoms are a number of particles. So we're going to divide by 22.4 liters per mole, and then we're going to multiply times 6 times 10 to the 23rd. So we'll go back and do that. We'll take the 82 liters, and we will take that times 1 mole over 22.4 liters. Liters will cancel, and then we'll take that times 6.02 times 10 to the 23rd. Atoms in a mole. Down here, we're going to take the 5 grams. And then we're going to divide by the molar mass to get to moles. Then we're going to multiply by the number. This is a molecule. And then we'll have to multiply by how many atoms are in the molecule. So this is going to be a 1, 2, 3-step problem on this one. So mass divided by molar mass will get me the moles. Then I'll multiply by 6 times 10 to the 23rd particles in a mole to get to the number of molecules. Then I'll multiply by the number of atoms in a molecule. So this is going to be a 3-stepper on this one. 3-stepper. So we'll go back, and we'll take this times 1 mole over H2 is going to be 2 grams in a mole. Then we'll take that times 6.02 times 10 to the 23rd. It's a molecule right now. Molecule in a mole of hydrogen. Then we'll take that by 2 atoms of hydrogen in a molecule of hydrogen. And you know what? I'm not going to be able to do this here. We'll just end up doing that. So this is equal to 82 over 22.4 times 6.02 times 10 to the 23rd. So we'll knock that out on the old calculator. 82 divided by 22.4 times 6.02 times 10 to the 23rd. And we get here 2.2. And we got 3 sig figs, so 2.20 times 10 to the 24th. Here we're going to take 5 divided by 2 times 6.02 times 10 to the 23rd times 2. So grams cancel, moles cancel, molecules cancel, and we have atoms. And this time I get a few more. I get 3.01 times 10 to the 24th. So this is more than this. Now this answer is actually smaller than this answer if you had not done this last step. So we hadn't multiplied by 2 here. This would have came out 1.5 times 10 to the 24th, and you would have thought there was more here. Well, let's get the ultimate here. Let's start at moles this time and get to number of formula units, and then we'll have to multiply by how many atoms are in that formula unit. So let's go back and look at this one, and I lost it there. There we go. So it's 1.80 moles of FeO. We'll multiply that by 6.02 times 10 to the 23rd formula units per mole of FeO. Then how many atoms are in that formula unit? 2. So 2 atoms per formula unit. 2 atoms of, there's just 2 atoms because there's one Fe and one O, so there's 2 atoms in every formula unit of FeO. So we'll take 1.8 times 6.02 times 10 to the 23rd times 2. And that comes out to be 2.17 times 10 to the 24th. So the lucky winner here, this is actually the least of all of them. Then this was a little more, and then that's even more. So our lucky winner is the hydrogen. 5 grams of hydrogen has more atoms in it than 1.8 moles of FeO, which has a little bit, well, and that's actually last, and the 82 liters of argon is second. So there we go. Biggie. Big problem on that one. All right, let's run her back to the next one. And that answer was incorrect there on A because they had not taken this times 2, and actually this one came out to be second. So an argon laser has 6.77 times 10 to the 24th atoms of argon in it. Calculate the number of moles of argon, and then the mass of the argon, and the volume of the argon. So this time what I'm going to have to do is do a bunch of different problems this time. I'm going to convert it to moles. We'll just get that answer, and then we're going to have to branch off. So we'll have to go from number of atoms of argon to moles of argon, and then they want us to go to how many atoms is it, and then they want us to go to how many liters is it. So we're going to have to go get this answer first, divide by the molar mass. Then we'll multiply by 22.4 per liter to get this, and then we'll multiply by 6 times 10 to the 23rd to get this. So we'll go back and do all those problems with that one. So that's going to be a little bit of work on this one. And so what we'll do on this one is we'll come up and we will do our little bit of adjusting here. And we will go ahead and take this thing so we can get rid of these problems. We'll get here. And we'll go 6.77 times 10 to the 24th atoms. I didn't do that correctly. We started atoms. We're going to go to grams. I did that one backwards. So we're going to take 1 mole over 6.02 times 10 to the 23rd atoms. So the number of moles is just this divided by this, and that's looks like that's going to be 11.2 moles of argon. Now, we can either go start back over from the beginning, or we can just take this answer and go on. That's what I'm going to do. I'm going to take the 11.2 moles, and I'm going to use it to get the other two answers. I'm going to take the 11.2 moles and multiply by 22.4 liters per mole to get the volume. I'll just take that answer times 22.4, and I get 252 liters. It's 3 sig figs again of argon. I'm going to go back, take my 11.2 moles, and I'm going to multiply that by the molar mass of argon, which in this case is 39.9 grams per mole, and that's going to be 447 grams of argon. So now we know that 6.77 times 10 to the 24th atoms of argon are 11.2 moles, which are 252 liters, at STP, of course, and 447 grams of argon. So that's a nice, delightful little problem where we can ask you a whole bunch of things about the same creature. And there you go. So we'll go look at number 17 now. Back on the worksheet. What's the molarity of a solution made by 12.8 grams of sodium nitrate in 7,500 milliliters of solution? So this time our molarity equation, first time we've used it on this page, will be molarity is moles of solute over liters of solution. So moles equals mass divided by molar mass. So we have 12.8 grams. And sodium nitrate is NaNO3. This is going to be a 23.0 plus a 14 plus 3 times 16, which is 48. And in that case, 23, 14, and 48. I could use my little app. And that's about 85 grams, 85.0 grams per mole. So we'll divide that by 85.0 grams per mole. And how many moles is that? So 12.8 divided by 85. Now you can stop and get an answer here. This is 0.151 moles. Okay. I'm going to go ahead and cut this off. So there's a couple ways we can do this. I'm going to go back and show you this. And then we would take this number of moles and we would divide that by the volume in liters. And the volume in liters, 7,500 milliliters, dot is, you have to divide by 1,000 to make it liters. So that's 7.500 liters. So 0.151 moles divided by 7.5 liters is pretty much exactly 0.0201 molar. Now let me do it a little differently here. 12.8 grams times 1 mole over 85 grams per mole divided by 7,500 milliliters times 1,000 milliliters over a liter. So these would cancel, grams would cancel, moles per liter, and you're going to get that same answer. So it looks like we aren't going to make it. We're going to have a part 4 coming up, and I hope you enjoy it, and that will be our last session. Hopefully you're enjoying these little videos. Let me know if you have any issues.